Everything you learned about human civilization is wrong, and I have the geological proof. The monumental structures at Göbekli Tepe in Turkey stand as silent witnesses to an advanced society that existed over 12,000 years ago, 6,000 years before the invention of the wheel. How did prehistoric hunter-gatherers move 20-ton limestone blocks with laser precision when they supposedly lacked even the most basic tools? In the next hour, I'll show you evidence that will force you to rewrite human history. But first, you need to understand what happened 12,800 years ago. Our story begins not with civilization, but with its near-complete destruction. Approximately 12,800 years ago, Earth experienced a catastrophic event that would forever alter the course of human history: the Younger Dryas impact. This wasn't a gentle transition, but a violent cosmic encounter that brought an advanced world to its knees. The evidence is written in the Earth itself. Across North America, Europe, and parts of Asia, scientists have discovered a distinct layer in the soil dating precisely to 12,800 years ago. This layer contains materials that simply shouldn't be there unless something truly extraordinary happened. Let's examine what geologists have found. First, there is an anomalous platinum spike. Platinum is extremely rare in Earth's crust, but common in asteroids and comets. This platinum anomaly has been documented across multiple continents, from Greenland ice cores to sediments in Syria. The platinum didn't come from our planet, it came from above. But platinum is just the beginning. The same soil layers contain nanodiamonds, microscopic diamonds formed only under conditions of extreme heat and pressure, exactly what you'd expect from a cosmic impact. These nanodiamonds appear simultaneously across the globe at the exact same geological moment. Conventional archaeology has no explanation for this. Even more telling are the microspherules, tiny glass beads created when rock is instantly melted and then rapidly cooled. These spherules contain iridium, osmium, and native iron, elements common in meteorites but exceedingly rare on Earth's surface. At sites like the recently discovered Louisiana Depression, researchers have recovered over a ton of melt glass formed at temperatures exceeding 2,200 degrees Celsius, far beyond what any natural Earth process could produce outside of a cosmic impact. The physical evidence doesn't stop there. Geologists have identified shocked quartz at numerous Younger Dryas boundary sites. These quartz crystals display distinctive fracture patterns that occur only under immense pressure, the kind generated by cosmic impacts or nuclear explosions. Nothing else can create these patterns. Dr. Richard Firestone of Lawrence Berkeley National Laboratory, alongside 25 other scientists, published groundbreaking research in the Proceedings of the National Academy of Sciences documenting these impact markers. Their findings faced fierce criticism initially, but subsequent studies have repeatedly confirmed their results. Independent teams working across 4 continents have verified the presence of these exotic materials, all appearing simultaneously in a thin layer marking the exact beginning of the Younger Dryas period. Notice the consistent dating of these materials, using multiple independent methods: radiocarbon dating, optically stimulated luminescence, stratigraphic analysis. Researchers have confirmed that these impact markers appeared precisely 12,800 years ago. This wasn't a slow process, but a sudden, catastrophic event that occurred within days or even hours. What does all this evidence tell us? It points unmistakably to a catastrophic event around 12,800 years ago. A comet or asteroid, likely fragmented, that exploded in the atmosphere above North America. This wasn't a single impact like the dinosaur-killing asteroid, but rather a series of airbursts that affected vast regions of the northern hemisphere. Here's what's fascinating. The pattern of material distribution suggests not a single large impact, but multiple airbursts across a wide area. Exactly what you'd expect from a fragmented comet entering Earth's atmosphere. The debris field stretches from modern-day Syria to the Channel Islands off California, covering nearly half the planet. The consequences were immediate and devastating. The explosive force ignited continent-wide wildfires, evidenced by a distinct black matte layer, a carbon rich deposit containing soot and charcoal, found above archaeological sites across North America. This black mat contains peaks in ammonium, nitrate, and carbon spherules, all indicators of massive burning. Look at the fossil record immediately above this layer. Up to 35 species of large mammals, including mammoths, mastodons, giant sloths, and American camels, disappeared almost overnight. North America lost nearly 70% of its large mammal species in what appears to be the most rapid extinction event in the continent's history. These weren't gradual disappearances, but sudden terminations of species that had thrived for millions of years. The environmental effects were equally dramatic. Temperatures plummeted by as much as 10 degrees Celsius in some regions, plunging the world back into Ice Age conditions for over 1,200 years. This wasn't a minor fluctuation, but a profound climate reversal that transformed lush landscapes into Arctic tundra within a human generation. This period of extreme cold is what scientists call the Younger Dryas, named after a cold, tolerant Arctic flower whose pollen suddenly became abundant in European lake sediments. The abrupt onset of this cold period has puzzled climatologists for decades. Traditional explanations involving gradual shifts in ocean circulation patterns simply can't account for the suddenness of the change or the presence of impact markers at precisely the same time. But while mainstream geology acknowledges the temperature drop, many still resist the impact hypothesis despite the mounting evidence. At scientific conferences, proponents of the Younger Dryas impact hypothesis face hostility and ridicule rather than engagement with their data. Their papers undergo extraordinary scrutiny before publication, while criticisms of their work sail through peer review with minimal verification. Why? Because accepting a cosmic impact means accepting that advanced human societies could have existed before this cataclysm and were subsequently wiped out, leaving only fragments and ruins for us to discover millennia later. The implications are profound. If an advanced civilization existed before this impact, where is the evidence? The answer lies in two places: beneath the oceans and at anomalous archaeological sites that have been systematically dismissed or marginalized by conventional archaeology. The geological record shows massive flooding followed the impact. As temperatures eventually warmed, ice sheets melted rapidly, raising global sea levels by more than 400 feet. This wasn't a gradual rise, but occurred in dramatic pulses, catastrophic meltwater, events that could raise sea levels by several meters within decades. Here's what most archaeologists won't tell you. During the last ice age, sea levels were dramatically lower than today. Coastal areas, which have always been prime locations for human settlement, extended many miles beyond current shorelines. These now submerged coastal plains would have been ideal habitats for advanced human societies, offering abundant marine resources, fertile land, and natural transportation networks. Coastal civilizations, likely the most advanced of their time, would have been completely submerged by the post-Younger Dryas sea level rise. This explains why so many ancient flood myths exist across disparate cultures worldwide, from the biblical account of Noah to the Mesopotamian epic of Gilgamesh, from the Hindu Puranas to indigenous American traditions. These aren't myths at all, but preserved memories of actual events. Consider the time scale. Sea levels rose dramatically between 11,000 and 8,000 years ago. Any evidence of coastal settlements from before this time now lies under hundreds of feet of ocean. We've barely begun to explore these underwater landscapes, yet already we're finding suggestive structures off the coasts of Japan, India, and Cuba. The Gulf of Cambay in India contains underwater structures extending over several kilometers. Structures that would have been above water before 7,500 BCE. Off the coast of Japan, the Yonaguni Monument shows precise angles and straight features that many researchers believe indicate human modification. Similar formations have been identified near Malta, Greece, and throughout the Mediterranean. But this is where mainstream archaeology becomes strangely resistant. Despite advances in underwater archaeology, there's been minimal systematic exploration of these submerged coastlines. When structures are found, they're typically dismissed as natural formations without thorough investigation. Research proposals focusing on potential pre-flood settlements struggle to secure funding, while expeditions to known Mesopotamian or Egyptian sites receive generous grants. This institutional resistance has created a self-reinforcing paradigm. Evidence of advanced pre-flood civilization is ignored because we know civilization began around 4000 BCE in Mesopotamia, and we know this because we haven't found evidence of earlier civilizations. It's circular reasoning, masked as scientific consensus. But the most compelling evidence isn't underwater at all. It survived on higher ground, deliberately built to withstand catastrophe. And this brings us back to perhaps the most remarkable archaeological site ever discovered, Göbekli Tepe. Mainstream archaeology places the birth of civilization in Mesopotamia around 6,000 years ago. Yet Göbekli Tepe, dated unequivocally to 9600 BCE using carbon-14 techniques, is twice that age. The site consists of multiple rings of massive T-shaped pillars, some weighing up to 10 tons, arranged in precise circles. These pillars are covered with sophisticated carvings of animals, symbols, and scenes that demonstrate advanced artistic ability and abstract thinking. When German archaeologist Klaus Schmidt began excavating Göbekli Tepe in 1994, he expected to find a modest Neolithic settlement. What he discovered instead was an archaeological impossibility: monumental architecture at a time when humans were supposedly simple hunter-gatherers wielding crude stone tools. The scale is staggering. Each stone pillar stands between 16 and 18 feet tall and weighs between 7 and 10 tons. These weren't rough-hewn rocks, but precisely carved monoliths transported from a limestone quarry over 500 meters away. The pillars are arranged in perfect circles, with the most impressive structures appearing in the oldest layers, exactly the opposite of what evolutionary archaeology would predict. Here's what's fascinating. Göbekli Tepe was built immediately after the Younger Dryas period ended. Its construction coincides exactly with the return of warmer temperatures around 9600 BCE. This timing is no coincidence. The builders possessed knowledge that predated the impact, knowledge that survived through the millennium of cold and darkness. The site contains advanced features that conventional archaeology struggles to explain. The pillars are arranged with precise astronomical alignments, tracking solstices and equinoxes with accuracy that requires generations of systematic observation. The carvings demonstrate sophisticated artistic conventions, perspective, proportional accuracy, and symbolic representation that supposedly wouldn't develop for thousands of years. But this is where it gets interesting. The pillars at Göbekli Tepe aren't just decorative. They contain astronomical alignments and symbolism that some researchers believe directly reference the cataclysmic event itself. Dr. Martin Sweatman, a chemical engineer from the University of Edinburgh, has analyzed the carvings on what's called the vulture stone at Göbekli Tepe. Using advanced statistical methods, he demonstrated that these symbols correspond to constellations visible in the night sky, specifically marking the date of the Younger Dryas impact with extraordinary precision. Sweatman's analysis, published in the Mediterranean Archaeology and Archaeometry journal, showed that the animal symbols on pillar, the vulture stone, represent specific star constellations in their positions at the time of the Younger Dryas event. The central figure, a vulture, corresponds to the constellation Sagittarius. Other animals match additional constellations in their exact configuration on the summer solstice of 10,950 BCE, precisely dating the Younger Dryas impact. This isn't vague symbolism or subjective interpretation. It's a specific astronomical record carved in stone, verified through statistical analysis and astronomical software. The probability of these alignments occurring by chance is less than 1 in a million. But conventional archaeology dismisses this research, not because of methodological flaws, but because it contradicts established chronologies. If Göbekli Tepe's builders were recording a celestial event from 3,000 years before their time, it implies continuous knowledge transmission through a sophisticated intellectual tradition. something that shouldn't exist in supposedly primitive hunter-gatherer societies. The builders of Göbekli Tepe weren't simple hunter-gatherers who suddenly decided to drag multi-ton stones across miles of rugged terrain. They were the inheritors, perhaps even survivors, of a sophisticated pre-impact culture that preserved crucial knowledge through an apocalyptic event. Yet mainstream archaeology continues to insist these structures were built by hunter-gatherers. With no prior architectural experience, no draft animals, no metal tools, and no wheel. Does this make logical sense? Or are we missing a critical chapter in human history? Look at the precision of these stone joints. Examine the perfect astronomical alignments. Consider the advanced understanding of engineering principles required to create structures that have stood for over 11,000 years. These aren't the works of primitive peoples. They're the remnants of a lost civilization, one that flourished before the flood and was nearly erased from history by a cosmic catastrophe. But if such an advanced civilization existed, why don't we find more evidence? The answer lies in the selective preservation of archaeological materials. Stone monuments can survive millennia of weathering and flooding, but more perishable aspects of civilization, wooden structures, textiles, papyrus or paper documents, even metal artifacts, degrade rapidly under most conditions. What we're seeing at sites like Göbekli Tepe are the most durable elements of ancient civilizations. Their monumental stone architecture designed specifically for long-term survival. These weren't their houses or administrative buildings, but their most sacred sites, deliberately constructed to preserve knowledge across vast spans of time. This explains another puzzling aspect of these ancient sites: their apparent focus on astronomical observation and timekeeping. If your civilization faced periodic cosmic threats, tracking celestial cycles would be an existential priority, a way to predict and prepare for future impacts. The astronomical alignments at Göbekli Tepe, Stonehenge, Newgrange, and other ancient sites may represent not mere ceremonial features but sophisticated warning systems designed to track threatening celestial objects. Consider the implications of Pillar 43 at Göbekli Tepe. If Sweatman's analysis is correct, its carvings record not just the Younger Dryas impact, but also the celestial configuration associated with it. This would allow future generations to recognize similar dangerous alignments and prepare accordingly. It's not mythology but practical astronomical knowledge encoded in stone. The vulture symbol is particularly significant. In many ancient cultures, vultures represented death and renewal. Precisely what a civilization would experience after a catastrophic impact. The scorpion symbol, corresponding to Scorpio, marks the exact point on the horizon where the dangerous, torrid meteor stream originates, the same stream implicated in the Younger Dryas impact. This isn't coincidental symbolism but precise astronomical record-keeping, designed to survive catastrophe and warn future generations. The builders of Göbekli Tepe weren't recording myths or decorating sacred spaces. They were preserving vital knowledge about cosmic cycles that had nearly destroyed their world. But conventional archaeology dismisses these interpretations because they contradict the established narrative of linear human progress, the comforting story that we've steadily advanced from primitive beginnings to our current technological sophistication without major setbacks or lost knowledge. The evidence at Göbekli Tepe suggests a very different history, one where advanced knowledge existed in deep antiquity, was partially lost during catastrophic events, and was deliberately preserved through monumental architecture designed to transmit specific information across millennia. This alternative history doesn't require aliens, supernatural powers, or unknown physics. It simply acknowledges that our ancestors were more sophisticated than conventional chronologies allow, and that cosmic catastrophes have periodically reset human civilization, forcing survivors to rebuild from fragments of preserved knowledge. At minute 47, I'll reveal what ground-penetrating radar found under Göbekli Tepe that archaeologists won't discuss publicly. This discovery alone challenges everything we've been taught about ancient human capabilities. But first, we need to examine other lines of evidence supporting the existence of advanced pre-flood civilizations. The Younger Dryas impact provides the mechanism for their destruction, and Göbekli Tepe offers a glimpse of their preserved knowledge. But these aren't isolated anomalies. They're part of a global pattern that conventional archaeology has systematically ignored or marginalized. The North American archaeological record shows a clear discontinuity at the Younger Dryas boundary. The Clovis culture, known for their distinctive fluted stone points, vanished precisely at this time. Above the boundary layer containing impact markers, Clovis points disappear, completely replaced by different technological traditions. This wasn't a gradual transition, but an abrupt termination coinciding exactly with the cosmic impact. Similar cultural discontinuities appear across Europe, the Middle East, and parts of Asia, all dating to the same narrow time window. Traditional archaeology attributes these changes to gradual climate shifts or population movements. But the simultaneity and abruptness of these transitions better match a catastrophic scenario. The environmental changes following the impact would have been equally dramatic. Massive wildfires, evidenced by charcoal and soot in the boundary layer, would have destroyed forests and grasslands across vast regions. The resulting smoke and dust, combined with water vapor from vaporized ice sheets, would have blocked sunlight and triggered the sudden cooling of the Younger Dryas period. The ice core record from Greenland reveals this abrupt cooling in stark detail. Temperatures dropped by as much as 15 degrees Celsius within decades, perhaps even within a single season. For populations adapted to the warming conditions at the end of the last ice age, this sudden return to glacial conditions would have been devastating. Adding to this catastrophe was the disruption of ocean circulation patterns. The enormous influx of fresh water from melting ice sheets and the impact itself appears to have shut down the North Atlantic circulation system that brings warm water from the tropics to northern latitudes. This oceanic disruption amplified and prolonged the cooling effect, transforming what might have been a brief impact winter into over a millennium of renewed ice age conditions. For any advanced civilizations existing at the time, these combined disasters, cosmic impact, massive wildfires, abrupt cooling, rising sea levels, would have been apocalyptic. Coastal settlements would have faced tsunami inundation followed by gradual submergence as sea levels rose. Inland populations would have confronted wildfires, crop failures, and rapid climate deterioration. Social complexity would have collapsed as survival became the only priority. Yet, not all knowledge would have been lost. Some groups, perhaps those with advanced astronomical understanding who anticipated the impact, might have prepared by building resilient structures in strategic locations. They would have preserved their most essential knowledge in durable forms, encoding it in monumental architecture designed to survive both catastrophe and time. This brings us to another crucial piece of evidence, the universal flood myths that appear in virtually every ancient culture. From the biblical Noah to the Mesopotamian Utnapishtim, from the Hindu Manu to the Greek Deucalion, diverse cultures share remarkably similar accounts of a global flood that destroyed an earlier world, with only a few survivors preserving essential knowledge. Conventional archaeology dismisses these accounts as imaginative responses to local flooding events. But when examined alongside the geological evidence for massive post-glacial flooding and the archaeological evidence for advanced pre-Younger Dryas societies, these traditions take on new significance. They may represent not myths, but preserved memories of actual events, accounts transmitted through generations to warn future societies about cosmic dangers. The details in many flood accounts are particularly telling. They often mention not just rising waters, but fire from the sky, stars falling to earth, and days of darkness, precisely what witnesses of the Younger Dryas impact would have experienced. They describe not just destruction, but the preservation of knowledge, sacred texts, astronomical information, construction techniques, exactly what survivors of an advanced civilization would prioritize saving. Perhaps most significantly, many traditions specifically mention the preservation of advanced knowledge. The Sumerian king list describes antediluvian rulers with impossibly long reigns followed by a great flood, after which kingship descended from heaven again, suggesting the reintroduction of civilization by survivors. Egyptian traditions speak of the first time Zep Tepi, when gods ruled on earth before a great catastrophe. Hindu texts describe previous world ages, yugas, of advanced achievement, ended by cosmic cycles of destruction and renewal. These aren't mere stories but encoded historical memories, accounts that preserved crucial information about cosmic catastrophes and the cyclical nature of civilization long before modern science rediscovered these patterns. The Younger Dryas impact hypothesis reconnects these ancient accounts with physical evidence, suggesting they contain more literal truth than modern scholars have acknowledged. When we integrate the geological evidence for cosmic impact with the archaeological evidence from sites like Göbekli Tepe and the cultural evidence preserved in ancient traditions, a coherent, alternative history emerges. One where advanced human societies existed before 12,800 years ago, were devastated by cosmic catastrophe, and were partially rebuilt by survivors who preserved crucial knowledge. This alternative chronology doesn't require spectacular technological achievements beyond what we know humans can accomplish. It simply pushes the timeline of social complexity back several thousand years and acknowledges that catastrophic events have periodically reset human civilization, destroying most evidence of previous achievements. The resistance to this perspective reveals more about modern academic institutions than about ancient history. Careers and reputations have been built on the conventional chronology that places the birth of civilization around 4000 BCE in Mesopotamia. Accepting evidence for advanced societies twice that age would invalidate countless books, papers, and established academic hierarchies. Yet the evidence continues to accumulate. New dating techniques consistently push human achievements further into the past. Sites like Göbekli Tepe demonstrate capabilities that shouldn't exist according to conventional timelines. And the Younger Dryas impact hypothesis provides a mechanism for why advanced ancient civilizations might have collapsed, leaving only fragments for us to discover millennia later. As we approach the halfway point in our investigation, the evidence points increasingly toward a radical conclusion: human civilization is far older than we've been taught, was nearly destroyed by cosmic catastrophe around 12,800 years ago, and was partially rebuilt by survivors who encoded their knowledge in monumental architecture designed to withstand both time and disaster. In the next chapter, we'll examine Göbekli Tepe more closely. Not just what has been excavated, but what ground-penetrating radar has revealed beneath the surface. This evidence, systematically marginalized by conventional archaeology, challenges everything we thought we knew about human capabilities in deep antiquity. But Göbekli Tepe isn't alone. There's a global pattern of anomalous sites that share sophisticated architectural features, despite being separated by vast oceans and supposedly having no contact with each other. This network of ancient sites forces us to confront an uncomfortable question: what if early human history isn't what we've been told? When German archaeologist Klaus Schmidt first began excavating Göbekli Tepe in 1994, he expected to find a relatively modest Neolithic settlement. What he discovered instead was so extraordinary that he would later remark, "First came the temple, then the city." This statement fundamentally contradicts everything archaeology had previously established about the development of human civilization. The conventional narrative tells us that humans first developed agriculture, which led to settled communities, which eventually grew into cities with specialized labor, which finally allowed for monumental architecture and complex religion. Göbekli Tepe completely inverts this sequence. Here was monumental architecture and complex symbolism before agriculture, before pottery, before metallurgy, before writing, before all the supposed prerequisites of civilization. Let's examine the facts that make Göbekli Tepe so anomalous. The site consists of multiple circular enclosures, each containing two central, T-shaped pillars surrounded by smaller pillars arranged along the perimeter. These T-pillars stand up to 18 feet tall and weigh between 7 and 10 tons each. They were quarried from limestone outcrops hundreds of meters away, shaped with unknown tools, transported without draft animals or wheels, and erected with astonishing precision. The dating is unequivocal. Using radiocarbon methods, the oldest layers of Göbekli Tepe date to approximately 9,600 BCE, over 11,500 years ago. This places its construction immediately after the end of the Younger Dryas Cold period, at a time when humans were supposedly simple hunter-gatherers living in small bands. But here's what's even more remarkable. The oldest layers of Göbekli Tepe contain the most sophisticated construction. The pillars in the deepest, earliest levels display the most complex carvings and the most precise stonework. Later layers show progressively simpler construction and less refined artistry. This suggests not a culture developing skills over time, but rather one that began with advanced knowledge that was gradually lost. This pattern, technological regression rather than progression, appears repeatedly at sites predating conventional civilization. It's the exact opposite of what archaeological theory predicts. Yet the evidence is unmistakable. The implications are profound. If the most sophisticated work appears in the oldest layers, these builders weren't developing their skills through trial and error. They arrived with established expertise that must have developed somewhere else, sometime earlier. But where and when? Conventional archaeology offers no satisfactory answers. Consider what it takes to create Göbekli Tepe's pillars. First, you need to locate suitable limestone deposits and extract blocks weighing up to 10 tons. This requires not just manpower, but knowledge of geology and stone properties. Next, you must transport these massive blocks over uneven terrain without wheeled vehicles or draft animals, both supposedly unavailable at this time. Then you must shape the stone using tools supposedly limited to flint, obsidian, and other stone implements. The precision of the stone cutting defies explanation using conventional tools. The T-shaped pillars have straight edges, flat surfaces, and precise 90-degree angles. Experimental archaeologists attempting to reproduce these results using Stone Age tools have consistently failed to achieve similar precision. Something doesn't add up in the conventional narrative. Once shaped, the pillars must be transported to their final location and erected in precise positions. This requires not just brute force, but sophisticated understanding of leverage, balance, and structural engineering. The pillars aren't simply placed on the ground, but are inserted into sockets, carved into bedrock, a technique requiring advanced planning and execution. Finally, the pillars are carved with detailed reliefs showing various animals, symbols, and abstract designs. These aren't crude sketches, but sophisticated artistic compositions demonstrating perspective, proportional accuracy, and symbolic representation. The artists had a developed visual language and advanced technical skill long before such capabilities were supposed to exist. The carvings themselves defy explanation. They include detailed depictions of animals that demonstrate sophisticated artistic conventions, three-dimensional representation, proportional accuracy, and abstract symbolism. Some pillars feature anthropomorphic elements, arms, hands, and garments, suggesting they represent humanoid figures rather than mere structural supports. The level of anatomical accuracy is particularly striking. The animal carvings show species-specific details that reveal intimate knowledge of their anatomy and behavior. The foxes, lions, bulls, and birds aren't generic representations, but precise renderings. That would require careful observation and established artistic tradition. Even more significant are the astronomical alignments. The main enclosures are oriented to track specific celestial events. Enclosure D aligns precisely with Sirius at certain dates, while other structures mark solstices and equinoxes. This demonstrates not just casual observation of the sky, but a deep understanding of celestial mechanics, knowledge that requires generations of systematic observation and record-keeping. The astronomical precision at Göbekli Tepe requires understanding the precession of the equinoxes, the gradual, shift in Earth's axial orientation that changes stellar alignments over a 26,000-year cycle. Detecting this subtle celestial movement requires multi-generational observation and accurate record-keeping over centuries. How could hunter-gatherers without writing systems accomplish this? The answer may lie in the symbolism encoded in Göbekli Tepe's carvings. Researcher Martin Sweatman's analysis suggests specific animal symbols correspond to constellations, creating a star map that not only marks the date of the Younger Dryas impact, but establishes a system for tracking its recurrence. This isn't primitive art, but sophisticated astronomical record-keeping encoded to survive catastrophe. The H and I symbols appearing repeatedly throughout the site may represent the constellation Orion in its summer and winter positions, precisely the region of the sky from which the dangerous Taurid meteor stream originates. This suggests Göbekli Tepe's primary function was astronomical monitoring, specifically tracking cosmic threats that had previously devastated human societies. This interpretation gained support from the site's location. Positioned on the highest point in the region with unobstructed views of the horizon, Göbekli Tepe offers ideal conditions for celestial observation. The arrangement of enclosures provides sightlines to key points on the horizon where significant stars rise and set. This wasn't random placement, but deliberate positioning for astronomical purposes. But perhaps the most compelling aspect of Göbekli Tepe is what it doesn't contain. There are no permanent living quarters, no evidence of agriculture in the earliest layers, no water source, and no signs of continuous occupation. This wasn't a settlement. It was a ceremonial center, a place where people gathered for purposes beyond mere survival. The question that haunts archaeologists is who built this? The conventional answer, that it was constructed by local hunter-gatherers who spontaneously developed the necessary skills, becomes less credible the more we learn. The planning, organization, and specialized knowledge required to build Göbekli Tepe strongly suggest the involvement of a previously established tradition of monumental architecture, one that must have existed before the Younger Dryas impact. We're looking at a culture that possessed advanced stone masonry techniques, sophisticated engineering knowledge, complex social organization, astronomical expertise, abstract symbolic thinking, long-term planning capabilities. These are the hallmarks not of simple hunter-gatherers, but of an established civilization. Yet according to conventional archaeology, no such civilization existed at this time. The social organization required for Göbekli Tepe's construction poses particular challenges to conventional theory. Building these structures would require hundreds of workers coordinated over extended periods. These workers would need food, shelter, and specialized training. In conventional models, hunter-gatherer societies lack the population density, food surplus, and organizational hierarchy necessary for such projects. Yet the evidence is unmistakable. Someone mobilized the resources, coordinated the labor, and directed the construction of these sophisticated structures at a time when such capabilities supposedly didn't exist. This contradiction can't be resolved within conventional archaeological frameworks without pushing the origins of social complexity much further into the past. The symbolism at Göbekli Tepe offers further clues about its builders. The site doesn't just display random animal carvings, but a coherent symbolic system repeated across multiple enclosures. Certain animals appear in consistent positions and relationships, suggesting they represent specific concepts within an established symbolic language. Most intriguing are the humanoid elements incorporated into many pillars. The T-shape itself appears to represent a stylized human form, with the crossbar as arms and the vertical shaft as body. Some pillars display hands, fingers, and what appear to be clothing or ornaments carved in relief. These aren't just supporting stones, but anthropomorphic representations, perhaps ancestral figures or deities within the builder's belief system. The belt and loincloth motifs appearing on central pillars suggest figures of authority or special status. Similar iconography appears in much later Mesopotamian and Egyptian art, where belts and specialized garments indicate rulership or divine status. This continuity suggests not independent invention, but cultural transmission. Across thousands of years, knowledge preserved despite catastrophic disruption. Now, let's address the most perplexing aspect of Göbekli Tepe, its deliberate burial. After standing for approximately 1,500 years, the entire complex was carefully and systematically covered with thousands of cubic meters of soil and debris. This wasn't natural sedimentation. It was an enormous coordinated effort to preserve the site by burying it. The excavation reveals distinct layers of infill, with different materials carefully placed in sequence. First came layers of occupation debris, broken tools, food remains, and other cultural materials. Then structural stones from upper portions of the buildings. Finally, tons of earth and limestone fragments, all transported to the site specifically for burial purposes. Why would a culture invest enormous resources to build monumental structures only to deliberately hide them? The conventional explanation that religious beliefs changed seems insufficient, given the scale of the undertaking. A more compelling hypothesis is that the builders foresaw another catastrophe and took steps to protect their most sacred knowledge. The burial preserved Göbekli Tepe almost perfectly for over 10,000 years. Without this deliberate act, erosion would have destroyed much of what we now see. Was this an act of preservation for future generations? Did the builders intend for the site to be rediscovered when humanity was ready to understand its message? Göbekli Tepe's astronomical alignments may provide a clue. Some researchers have identified carvings that appear to reference the Taurid meteor stream, the same celestial body implicated in the Younger Dryas impact. If accurate, this suggests Göbekli Tepe wasn't just a temple, but a warning system, a way of tracking the cyclical return of the cosmic threat that had nearly destroyed humanity once before. The H and I glyphs appearing repeatedly throughout the site have been interpreted by some researchers as representing the constellation Orion during summer and winter positions. Orion is precisely the area of the sky from which the Taurid meteor stream originates. Was Göbekli Tepe built specifically to monitor this threat? This theory gains further support from a carved stone pillar discovered at the site, known as the Vulture Stone. This pillar appears to depict astronomical events, using animal symbols as constellations. When interpreted as a star map and dated using precession calculations, it corresponds precisely to the time of the Younger Dryas impact, approximately 12,800 years ago. The central image on the Vulture Stone shows a headless human figure, perhaps representing death or catastrophe, surrounded by animals that match specific constellations in their positions during the Younger Dryas period. The vulture or eagle corresponds to Sagittarius, the scorpion to Scorpio, and other animals to additional constellations. Together, they mark not just a date, but the specific celestial alignment associated with cosmic disaster. If this interpretation is correct, Göbekli Tepe represents not just a temple, but a sophisticated astronomical instrument, a device for tracking celestial cycles associated with periodic catastrophe. Its builders weren't engaging in primitive worship, but sophisticated science, encoding critical knowledge about cosmic threats in durable stone. This function would explain both the site's construction and its deliberate burial. If Göbekli Tepe served as an astronomical warning system, its creators would have recognized its crucial importance for future generations. They would have invested enormous resources in its construction and taken extraordinary measures to ensure its preservation, including burial when they recognized another potential threat approaching. The dating supports this hypothesis. Göbekli Tepe was built immediately after the Younger Dryas period ended, when survivors would have been acutely aware of cosmic dangers and motivated to create warning systems. It remained in use for approximately 1,500 years, long enough for several generations to maintain its astronomical functions and transmit knowledge about its purpose. Then, around 8000 BCE, it was deliberately buried. This timing coincides with another period of climate instability and rising sea levels. Perhaps its custodians recognized another potential catastrophe approaching and took steps to preserve their knowledge by burying the site hoping future generations would rediscover and understand its message. This interpretation transforms our understanding of Göbekli Tepe from a primitive religious site to a sophisticated, scientific instrument created by people with advanced astronomical knowledge and profound concern for human survival. It suggests not simple hunter-gatherers but heirs to an advanced tradition nearly erased by cosmic catastrophe. But Göbekli Tepe isn't alone. Its architectural style, symbolic language, and astronomical focus connect it to other anomalous sites across the ancient world. And this brings us to our next revelation, what appears to be an interconnected network of advanced sites that predate conventional civilization, sites that share impossible similarities despite being separated by vast distances. From Malta's megalithic temples to Britain's Stonehenge, from Egypt's Sphinx to Easter Island's Moai statues, we find sites that share specific architectural features, astronomical alignments, and symbolic systems. These connections suggest not independent invention, but a common source, perhaps survivors, of the Younger Dryas catastrophe who carried their knowledge to different regions. The Maltese temples, dated to around 3600 BCE, share Göbekli Tepe's focus on astronomical alignment and symbolic carving. Stonehenge, with construction phases beginning around 3000 BCE, demonstrates the same preoccupation with celestial cycles and precise stellar tracking. Egypt's Sphinx, which geological evidence suggests may be thousands of years older than conventionally recognized, shows weathering patterns consistent with rainfall during the pre-Younger Dryas period. These connections become even more compelling when we examine their symbolic systems. Certain motifs, spiral patterns, concentric circles, specific animal groupings, appear repeatedly across sites separated by vast distances and supposedly isolated from each other. These aren't simple designs that might be independently invented, but complex symbolic systems that suggest common cultural origin. How did these similarities develop in supposedly isolated hunter-gatherer cultures? The conventional answer, independent invention, becomes increasingly strained as more connections emerge. A more straightforward explanation is that these sites were built by groups sharing a common cultural heritage, survivors of a worldwide catastrophe who carried their knowledge to different regions. This network of sites suggests not just isolated pockets of advanced knowledge, but an integrated system for preserving crucial information across vast spans of time. Each site emphasizes slightly different aspects of this knowledge: astronomical in some, mathematical in others, architectural in still others. But together, they form a coherent body of information about celestial cycles, catastrophic events, and survival strategies. Göbekli Tepe stands as the smoking gun in the case for an advanced pre-flood civilization. Its mere existence forces us to reconsider everything we thought we knew about human capabilities in deep antiquity. If such sophisticated structures could be built over 11,500 years ago, what else might our ancestors have achieved that has been lost to time or submerged beneath rising seas? The implications are profound. Either we accept that hunter-gatherers with no prior architectural experience suddenly developed the skills to create monumental precision-engineered structures, a scenario that defies both logic and the archaeological record, or we acknowledge that an advanced civilization existed before the Younger Dryas impact, a civilization whose survivors helped rebuild human society in its aftermath. The latter explanation aligns not only with the archaeological evidence, but with ancient traditions worldwide. From Sumerian accounts of the Anunnaki who brought knowledge after the flood to Plato's description of Atlantis destroyed by natural disaster, from Hindu texts describing previous world ages to Maya accounts of successive creations and destructions, diverse cultures share remarkably similar accounts of advanced civilizations ended by catastrophe, with knowledge preserved by survivors. These traditions were long dismissed as myths or metaphors. But when examined alongside the geological evidence for the Younger Dryas impact and the archaeological evidence from sites like Göbekli Tepe, they take on new significance. Perhaps they preserve actual historical memories, accounts transmitted through countless generations to warn future societies about cosmic dangers, and preserve crucial knowledge for rebuilding after catastrophe. What makes Göbekli Tepe particularly significant in this context is its deliberate construction as a knowledge preservation device. Its massive stone pillars, precisely aligned to astronomical events and carved with symbolic information, represent a conscious attempt to encode complex information in a form that could survive catastrophe and communicate across vast spans of time. This wasn't primitive religion, but sophisticated information technology, a durable, physical database designed to survive when more fragile records would be destroyed. The stone pillars would endure even through flood, fire, or cosmic impact. Their astronomical alignments would remain meaningful regardless of language or cultural change. And their symbolic carvings could convey complex information to anyone who understood their code. This perspective transforms how we view not just Göbekli Tepe, but all megalithic structures worldwide. Perhaps they weren't primarily temples, tombs, or monuments, but information storage and transmission devices, physical databases encoding crucial knowledge about celestial cycles, catastrophic events, and survival strategies. Their massive scale and durable materials ensured survival through catastrophe. Their precise astronomical alignments provided dating mechanisms that would remain accurate despite cultural disruption. And their symbolic carvings encoded specific information comprehensible to initiates trained in their interpretation. This function would explain why ancient peoples worldwide invested such enormous resources in megalithic construction. These weren't extravagant monuments to rulers or gods, but essential technologies for preserving knowledge through catastrophe. The ancient equivalent of our modern seed vaults and data repositories designed to survive global disaster. Göbekli Tepe represents perhaps the oldest and most sophisticated example of this knowledge preservation technology. Its construction immediately after the Younger Dryas catastrophe, its precise astronomical alignments, its sophisticated symbolic system, and its deliberate burial for preservation all suggest conscious design as an information transmission device across time. But the knowledge encoded at Göbekli Tepe wasn't intended just for its builders' immediate descendants. The scale and durability of the site suggest much longer time horizons, perhaps anticipating the complete collapse of their civilization and hoping future societies would rediscover and decipher their message. This long-term perspective appears in other megalithic sites worldwide, from Stonehenge's precise astronomical alignments to the mathematical constants encoded in the Great Pyramid, from Malta's underground hypogea to Easter Island's Moai statues, all demonstrate concern not just with immediate religious or political needs, but with transmitting specific knowledge across millennia. This perspective resolves many archaeological paradoxes. It explains why pre-literate societies invested such enormous resources in megalithic construction. It accounts for the precise astronomical alignments found at sites worldwide. It elucidates the sophisticated mathematical knowledge encoded in ancient structures. And it clarifies why certain symbolic systems appear across supposedly isolated cultures. Göbekli Tepe stands as the earliest and perhaps most important node in this global network of knowledge preservation sites. Its construction immediately after the Younger Dryas catastrophe represents humanity's first documented attempt to ensure crucial information would survive future disasters, a physical database designed to endure when all else failed. The site's deliberate burial around 8000 BCE may represent not abandonment, but the final phase of its design. Preservation through burial when its custodians recognized another potential catastrophe approaching. This wasn't ritual closure, but technological preservation, ensuring the information encoded in its pillars would survive intact until future generations could rediscover and interpret it. But Göbekli Tepe isn't alone. There's a global pattern of anomalous sites that share sophisticated architectural features, despite being separated by vast oceans and supposedly having no contact with each other. This network of ancient sites forces us to confront an uncomfortable question. What if early human history isn't what we've been told? What if human civilization is far older than conventionally recognized? What if advanced societies existed before the Younger Dryas impact, were devastated by cosmic catastrophe, and were partially rebuilt by survivors who preserved crucial knowledge? What if megalithic sites worldwide represent not primitive monuments, but sophisticated information technologies, designed to transmit specific knowledge across catastrophic breaks in human civilization? These questions challenge not just archaeological chronologies, but our entire understanding of human history and potential. They suggest our ancestors achieved far more than we've recognized, and that our current civilization may represent not the apex of human achievement, but one cycle in a much longer and more complex story of advancement, catastrophe, and rebuilding. As we explore the global network of these anomalous sites in our next chapter, these connections become increasingly difficult to dismiss. The evidence points toward a radical conclusion. Human civilization is far older, more sophisticated, and more interconnected than conventional archaeology acknowledges. And the proof lies not in speculative theories, but in massive stone structures still standing after thousands of years. Physical databases designed by our ancestors to ensure their hard-won knowledge would survive even through apocalyptic destruction. But this raises a troubling question for modern civilization. If our ancestors recognized cosmic threats and took such extraordinary measures to warn future generations, why aren't we paying attention to their message? The astronomical alignments at Göbekli Tepe and similar sites worldwide may represent not primitive superstition, but sophisticated scientific observation, tracking celestial cycles associated with periodic catastrophe. Are we wise enough to decipher and heed their warning? In our next chapter, we'll examine the global network of sites connected to Göbekli Tepe, structure sharing impossible similarities despite their separation by vast distances and supposedly independent development. These connections provide compelling evidence for a shared cultural heritage predating conventional civilization, perhaps the scattered remnants of knowledge preserved by survivors of a cosmic catastrophe that nearly erased advanced human societies from Earth's surface. While Göbekli Tepe has captured archaeological attention, it represents just one node in what appears to be a global network of anomalous ancient sites, structures that share sophisticated features despite predating conventional civilization. These connections suggest not isolated developments but a shared cultural heritage spanning continents. Let's begin our global journey with Gunung Padang in Indonesia, a site that challenges Göbekli Tepe's status as the world's oldest monumental structure. Located on the island of Java, Gunung Padang was long dismissed as a natural hill with some minor stone constructions on top. Recent geological surveys and carbon dating have revealed something far more extraordinary. Using ground-penetrating radar, seismic tomography, and core drilling, researchers, led by geologist Dr. Danny Hillman Natawajaja, discovered that Gunung Padang is not a natural hill at all. It's an entirely artificial pyramid-like structure with multiple layers built over thousands of years. The deepest and oldest layers date to approximately 25,000 years ago, more than twice the age of Göbekli Tepe, and predating the Younger Dryas impact by over 12,000 years. Notice the distinctive pattern in the radar imaging. These aren't random geological formations, but ordered geometric structures with clear architectural features. The construction consists of columnar basalt blocks arranged in precise geometrical patterns, with evidence of cement-like binding material between stones. This binding material, an advanced ancient concrete, contains minerals that shouldn't naturally occur together, suggesting intentional formulation. Here's what's fascinating. Core samples from 15 meters deep have yielded organic material carbon dated to 25,000 BCE. These dates haven't been published in a single, isolated study but verified by multiple laboratories using different methodological approaches. If these dates are accurate, and the evidence strongly suggests they are, then human beings were creating monumental architecture at a time when they were supposedly primitive hunter-gatherers barely surviving the last ice age. What makes Gunung Padang particularly significant is its internal structure. Ground-penetrating radar has revealed chambers and structures inside the artificial mound, including what appears to be a large chamber approximately 16 meters below the surface. The sophistication of these internal spaces suggests not just piled stones, but carefully engineered architecture. But this is where mainstream archaeology becomes strangely resistant. Despite multiple peer-reviewed papers documenting these findings, conventional archaeologists dismiss Gunung Padang's extreme antiquity without examining the evidence in detail. Research proposals for more extensive excavation face bureaucratic obstacles and funding challenges. It's as if there's an institutional allergy to evidence that might push human architectural achievements tens of thousands of years into the past. The reluctance to acknowledge Gunung Padang's true age seems rooted not in scientific skepticism, but in the threat it poses to establish chronologies of human civilization. If humans were building monumental structures 25,000 years ago, entire careers based on the conventional narrative would require revision. Textbooks would need rewriting. Academic hierarchies would face disruption. Yet the dating techniques used at Gunung Padang are the same ones employed at less controversial sites. The researchers involved aren't fringe pseudoscientists, but respected professionals with advanced degrees and institutional affiliations. The double standard in evaluating their evidence reveals more about academic politics than scientific methodology. Now let's move beneath the waves to examine underwater structures that may represent settlements from before the post-glacial sea level rise. Off the coast of Yonaguni Island in Japan, divers discovered a massive underwater monument in 1987. The structure includes platforms, straight walls, steps, columns, and what appears to be a road, all cut into bedrock and now submerged 25 meters below sea level. While mainstream geologists argue that the monument is a natural formation shaped by unique erosion patterns, others point to right angles, parallel faces, and symmetrical features that strongly suggest human modification. Look at these perfectly straight edges and right angles. Compare them to known natural formations in the region. The difference is striking. While nature occasionally produces geometric patterns through fracturing, the consistency and complexity of these features strongly suggest intentional shaping. The 2-meter-wide roads running along the structure maintain consistent width and direction. Across irregular terrain, a pattern highly unlikely to occur through natural processes. The site's location is critical to our timeline. Sea level data indicates that the area where the Yonaguni monument stands was last above water approximately 10,000 years ago, precisely when the vast ice sheets were melting after the Younger Dryas period. If the structure is artificial, or even partially modified by humans, it represents work done before the area was submerged, placing advanced stone working at least 10,000 years into the past. Even more compelling underwater evidence comes from India's Gulf of Cambay, now called the Gulf of Combat. In 2001, India's National Institute of Ocean Technology was conducting routine pollution studies when their side-scan sonar detected unexpected geometric structures on the sea floor, 40 meters below the surface. Further investigation revealed two large, distinct settlements extending over several kilometers. The grid pattern layout clearly shows streets intersecting at right angles, a planned urban arrangement. Dredged samples recovered from the site included human remains, pottery fragments, carved wood, stone tools, and even jewelry. Carbon dating of organic materials yielded ages between 7,500 and 9,500 years, older than any previously recognized urban civilization in the region. Here's what's remarkable. These weren't primitive settlements, but sophisticated urban centers, with evidence of advanced planning, water management systems, and monumental architecture. The Gulf of Cambay structures lie in an area that would have been submerged by rising sea levels approximately 7,500 to 8,000 years ago. Their location and age align perfectly with the post-glacial flooding scenario that followed the Younger Dryas period. These weren't small fishing villages, but extensive urban settlements with grid-patterned streets and evidence of advanced planning, at a time when humans were supposedly just beginning to experiment with agriculture. The conventional response to these discoveries has been predictable: dismissal without thorough investigation. Despite compelling sonar imagery and physically recovered artifacts, mainstream archaeology has largely ignored these findings. Research funding for underwater archaeology remains minuscule compared to terrestrial sites, despite the potential for discovering evidence of early civilizations on now submerged coastal plains. Similar underwater sites have been identified off the coast of Cuba, Malta, and Greece. In each case, the structures lie at depths corresponding to coastlines that existed before the dramatic sea level rise following the last ice age. Off Cuba's western coast, Canadian researchers using advanced sonar equipment discovered what appears to be an ancient urban complex 700 meters below the surface. The sonar images reveal geometric structures covering over 20 square kilometers, including pyramids, roads, and buildings. The depth places these structures underwater for at least 12,000 years, a timeline that aligns precisely with the end of the last ice age and the Younger Dryas event. Near Malta, divers have documented cart ruts and other structural features continuing from land directly into the sea, disappearing under rising water levels. These features match identical patterns on land that are recognized as ancient transportation networks, suggesting continuous habitation across areas now submerged by rising seas. When we map these underwater sites alongside known terrestrial monuments of extraordinary age, a pattern emerges. They align remarkably well with pre-flood coastlines. Ancient people, like modern ones, tended to build their most significant settlements along coasts and major waterways. As sea levels rose by over 400 feet, these coastal sites would have been the first to be submerged, explaining why we find relatively few traces of advanced prehistoric civilizations despite mounting evidence for their existence. But the global connections extend beyond location to include architectural and symbolic similarities that defy conventional explanation. Consider the phenomenon of megalithic construction, the use of enormous stone blocks fitted together with extraordinary precision. This building technique appears almost simultaneously across multiple continents following the Younger Dryas period. From Göbekli Tepe in Turkey to Puma Punku in Bolivia, from Easter Island to the Osirion in Egypt, we find massive stone blocks, often weighing many tons, cut and fitted with such precision that a modern playing card cannot be inserted between them. Look at these massive limestone blocks at Puma Punku in Bolivia. Some weigh over 100 tons yet are cut with perfect right angles and fitted with precision measured to within fractions of a millimeter. Compare them to the equally precise stonework at Göbekli Tepe, built on the opposite side of the world thousands of years earlier. The technical similarities are unmistakable despite the vast distances separating these sites. Conventional archaeology struggles to explain how supposedly primitive cultures, separated by vast oceans and lacking written communication, independently developed identical construction techniques requiring advanced understanding of geometry, physics, and engineering. The simpler explanation that these techniques derive from a common source is rejected, not because of evidence, but because it contradicts established chronologies. The official explanation relies on remarkable coincidence that people on different continents independently discovered identical techniques for quarrying, transporting, cutting, and fitting massive stone blocks with micrometric precision. This stretches credibility beyond reasonable limits. The principles of Occam's razor suggest a simpler explanation. These techniques derive from a common cultural source. Even more compelling are the symbolic connections between these sites. Certain motifs appear repeatedly across continents, the three-tiered world represented by a bird, serpent, and jaguar lion, astronomical alignments to specific star, clusters like the Pleiades, flood myths featuring survivors who bring knowledge to rebuild, civilization, and the use of specific mathematical constants in architectural design. Take, for example, the ratio 3:2:1, a proportion found in structures as diverse as the Great Pyramid of Giza, the Temple Mayor in Tenochtitlan, and certain enclosures at Göbekli Tepe. This ratio has astronomical significance related to the precession of the equinoxes, a celestial cycle that takes nearly 26,000 years to complete and requires sophisticated multi-to-generational observation to detect. This ratio isn't arbitrary, but precisely corresponds to mathematical relationships found in precession calculations. Embedding these ratios in monumental architecture suggests not decorative preference but deliberate encoding of astronomical knowledge, a method for preserving complex mathematical information across vast spans of time without written language. How did supposedly isolated cultures all recognize and incorporate this same astronomical knowledge into their most sacred structures? The conventional answer, coincidence, becomes increasingly implausible as more connections emerge. The similarity extends to construction techniques that would challenge modern builders. At both Cusco in Peru and Baalbek in Lebanon, we find polygonal masonry featuring stones with 12 or more sides, each fitting perfectly with its neighbors along complex three-dimensional joints. This technique requires not just advanced cutting tools, but sophisticated spatial visualization and engineering knowledge. Compare these polygonal walls in Peru with similar constructions in ancient Greece and Egypt. The technical approach is identical despite vast oceanic separation and supposed isolation. Both use the principle of non-rectangular blocks with complex interlocking faces to create earthquake-resistant structures. Both demonstrate precise cutting and fitting without mortar. Both show greatest technical sophistication in the oldest layers, with later repairs showing inferior technique. This pattern appears repeatedly at ancient sites worldwide. The oldest construction demonstrates the most advanced technical capability, with later additions showing progressive technical decline. This contradicts conventional models of gradual technological development but aligns perfectly with a scenario where survivors of an advanced civilization preserved critical knowledge that gradually degraded over subsequent generations. But perhaps the most significant connection between these global sites is their common theme of astronomical observation, specifically their focus on tracking celestial cycles related to potential cosmic threats. Many ancient sites function as precise astronomical observatories. Structures like Göbekli Tepe, Stonehenge, Newgrange in Ireland, and various Mesoamerican pyramids demonstrate their builders' ability to track solar and lunar movements with remarkable accuracy. They also show particular attention to the Taurid meteor stream, the same celestial body implicated in the Younger Dryas impact. Newgrange in Ireland, constructed around 3200 BCE, features a roof box specifically designed to allow sunlight to penetrate its internal chamber only at winter solstice sunrise. This alignment requires understanding not just seasonal solar positions but subtle shifts caused by precession. Similar precise alignments appear at sites worldwide, often incorporating awareness of precessional movement that should have been undetectable without multi-generational observation. This shared astronomical focus suggests these structures served a common purpose, monitoring the skies for signs of returning cosmic threats. If human civilization had indeed been devastated by a cosmic impact around 12,800 years ago, survivors would have had powerful motivation to develop warning systems to prevent future catastrophes. When we examine the global distribution of these astronomically aligned sites, another pattern emerges. They appear to have been positioned strategically to observe different portions of the night sky, creating a kind of worldwide early warning network. This level of coordination implies communication and shared purpose on a scale conventional archaeology does not recognize for this period. Consider the global distribution of sites aligned to the Pleiades star cluster. From Göbekli Tepe to the Great Pyramid, from Teotihuacan in Mexico to Angkor Wat in Cambodia, diverse cultures, separated by vast distances and millennia, all demonstrated special attention to this particular star group. Why this specific cluster? Research suggests the Pleiades may mark the origin point of periodic meteor showers associated with the Taurid stream, precisely the celestial body implicated in the Younger Dryas impact. The similarity between distant sites extends to construction techniques that would be remarkable even today. At both Pumapunku in Bolivia and the Osirian in Egypt, we find evidence of advanced stone-cutting technology. Perfectly straight cuts, precise right angles, and complex interlocking joints that would challenge modern stonemasons equipped with power tools. Look at this drill core from ancient Egypt, showing a perfect spiral cut through solid granite. Experimental archaeologists using copper tools and abrasives have consistently failed to reproduce these results. The spiral pattern indicates a drilling rate of penetration that exceeds what's possible with primitive tools. Similar precisely drilled holes appear at Pumapunku, Easter Island, and other sites worldwide. Mainstream archaeology attributes these feats to copper chisels, stone hammers, and abundant manpower. Yet experimental archaeology has repeatedly failed to reproduce these results using the proposed primitive methods. The stones at Pumapunku, for instance, include H-shaped blocks with complex internal angles cut with perfect precision in andesite, one of the hardest stones available. Modern stonemasons with power tools would struggle to achieve similar results. This contradiction between theoretical explanation and physical evidence reveals a fundamental problem in conventional archaeological thinking. Rather than adjusting theories to match evidence, mainstream archaeology often dismisses or ignores evidence that contradicts established paradigms. The global pattern becomes even more compelling when we consider the chronology. Many of these sites date to within a few thousand years after the Younger Dryas impact, precisely when we would expect survivors of a global catastrophe to begin rebuilding. Their focus on astronomical observation, their use of flood-resistant construction techniques, and their preservation of mathematical and scientific knowledge all suggest a response to recent disaster. This brings us to perhaps the most provocative question. Did these sites represent an attempt by survivors to preserve and transmit crucial knowledge to future generations? Were they a kind of insurance policy against the loss of civilization? The deliberate burial of Göbekli Tepe, the astronomical alignments of Newgrange and Stonehenge, the mathematical constants encoded in the Great Pyramid, all suggest attempts to preserve information across vast spans of time. These weren't merely religious monuments, but repositories of knowledge designed to survive catastrophe. Consider the information density in these structures. The Great Pyramid's dimensions encode multiple mathematical constants, including pi and phi, the exact length of Earth, solar year, the precise ratio of Earth's polar radius to its equatorial radius, and other astronomical values. These relationships aren't approximate but precise to several decimal places. This isn't random coincidence, but deliberate encoding of scientific knowledge in architectural form. Similarly, Göbekli Tepe's pillars contain astronomical information that maintained its relevance despite thousands of years of precession. The builders understood that stellar positions shift over time and designed their monuments to account for these changes, creating self-calibrating calendars that would remain accurate across vast time periods. When we map the global distribution of these anomalous sites against the regions most affected by post-glacial flooding, we find they cluster along former coastlines and in highlands that would have remained above water. This distribution suggests not random development, but strategic positioning by peoples who understood the threat posed by rising seas and sought to preserve their knowledge in locations that would remain accessible. The implications are profound. If these sites represent nodes in a global network of knowledge preservation built by survivors of a cosmic catastrophe, then human civilization is far older and more sophisticated than conventional archaeology acknowledges. The similarities between distant sites aren't coincidental, but evidence of a shared cultural heritage. One that predates known history and challenges our understanding of human capabilities in deep antiquity. But this global network poses a troubling question for mainstream archaeology. If these sites share so many sophisticated features, why is there such resistance to acknowledging their connections? The answer lies not in evidence, but in the paradigm that governs archaeological interpretation a paradigm that places the birth of civilization firmly in the Middle East around 6,000 years ago and resists any evidence that contradicts this established timeline. This resistance becomes especially puzzling when we consider that many ancient texts explicitly describe a global catastrophe, followed by a rebuilding of civilization by survivors who brought advanced knowledge from their destroyed homeland. From the Epic of Gilgamesh to Plato's account of Atlantis, from the Maya Popol Vuh to Hindu texts describing previous world ages, diverse cultures share remarkably similar accounts of advanced civilizations destroyed by flood and cosmic fire. The Sumerian king list, for example, describes a series of rulers with impossibly long reigns followed by a great flood, after which kingship descended from heaven again. This account parallels dozens of similar traditions worldwide that describe advanced knowledge coming from survivors of a destroyed civilization. These weren't creative myths, but attempts to preserve historical memory across generations. For centuries, these accounts were dismissed as mere myths. Now, with geological confirmation of a cosmic impact, followed by massive flooding at precisely the time described in many of these traditions, perhaps we should reconsider whether these stories preserve actual historical memories rather than imaginative fiction. Look at the striking parallels in flood myths worldwide. They typically describe not just rising water, but a sequence of events matching exactly what we'd expect from the Younger Dryas impact: fire from the sky, massive earthquakes, darkness covering the world, followed by devastating floods. These accounts appear in cultures with no contact with each other, yet share specific details that match the geological evidence for cosmic impact, followed by rapid sea level rise. The global network of anomalous ancient sites offers physical evidence that supports these accounts. Together, they suggest a very different narrative of human civilization, one in which advanced societies existed before the Younger Dryas catastrophe were largely destroyed by cosmic impact and subsequent flooding, and were rebuilt by survivors who preserved crucial knowledge and distributed it around the world. This alternative chronology doesn't require aliens, supernatural powers, or lost physics. It simply pushes the timeline of human achievement back several thousand years and acknowledges that our ancestors were more capable than we've given them credit for. Yet this modest revision to history faces fierce resistance from established archaeology. Resistance that seems motivated more by institutional inertia than by objective evaluation of evidence. Let's examine some specific connections between distant sites that challenge conventional explanation. The raised platform construction technique appears at sites from Göbekli Tepe to the earliest Egyptian temples, from Malta's megalithic structures to Easter Island's Ahu platforms. In each case, massive stone blocks create elevated surfaces oriented to specific celestial alignments. This construction method serves both practical purposes, protection from flooding, and astronomical functions for celestial observation. Similarly, the technique of creating perfectly fitted polygonal masonry appears in Peru, Egypt, Easter Island, and Greece. This isn't simple wall building, but a sophisticated engineering approach that creates earthquake-resistant structures through precise three-dimensional stone fitting. The mathematical knowledge required for this technique involves complex spatial geometry beyond what conventional timelines allow for these cultures. Even more compelling are the symbolic parallels. The tri-level cosmos, represented by bird, upper world, serpent, underworld, and jaguar, or lion, middle world, appears in iconography from Turkey to Mexico, from Egypt to China. This isn't a simple concept likely to be independently invented, but a specific cosmological framework shared across supposedly isolated cultures. The Ouroboros symbol, a serpent eating its own tail, likewise appears worldwide, often in contexts related to cyclical destruction and renewal. This specific symbol emerges in Egypt, Norse mythology, Mesoamerica, and ancient Greece, frequently associated with accounts of cosmic cycles and periodic catastrophe. These connections become particularly significant when we consider the difficulty of cultural transmission across vast oceans using conventional technology. How did identical architectural techniques, mathematical knowledge, and symbolic systems appear simultaneously across continents supposedly isolated from each other? The conventional answer, independent invention, becomes increasingly implausible as more parallels emerge. A more straightforward explanation is that these shared elements derive from a common source: survivors of an advanced civilization destroyed by the Younger Dryas impact, who carried their knowledge to different regions. This scenario explains both the similarities between distant sites and their emergence shortly after the catastrophic events that ended the last ice age. This perspective also explains why these sites share a preoccupation with astronomical observation and timekeeping. If your civilization had been destroyed by a cosmic impact, tracking celestial cycles to predict similar future events would become an existential priority. The astronomical alignments at ancient sites worldwide may represent not primitive sun worship, but sophisticated efforts to monitor cosmic threats and warn future generations. Consider Serpent Mound in Ohio, a 1,370-foot earthwork precisely aligned with solar solstices and lunar extremes. Recent carbon dating places its construction shortly after a cosmic airburst devastated the region around 11,000 years ago. The serpent's head aligns exactly with sunset on summer solstice, while the coils mark other key astronomical positions. This wasn't decorative art, but a functional calendar designed to track celestial cycles associated with periodic cosmic threats. Similar astronomical alignments appear at sites worldwide, often incorporating awareness of precession, the subtle 26,000-year cycle that shifts stellar positions over millennia. Tracking this cycle requires multi-generational observation and record-keeping, yet evidence of precessional knowledge appears at sites dating to the early post to Younger Dryas period. The global network of these astronomically aligned sites suggests a coordinated response to cosmic catastrophe, an effort by survivors to create an early warning system that could help prevent future disasters. These weren't isolated developments, but nodes in an integrated monitoring system spanning continents. When we map the distribution of these sites against what we know about post-glacial flooding, another pattern emerges. They cluster along former coastlines and in highlands that would have remained above water during sea level rise. This distribution suggests not random development, but strategic positioning by peoples who understood the threat posed by rising seas. But perhaps the most compelling evidence for a global knowledge network comes from the mathematical and scientific information encoded in these ancient structures. The Great Pyramid doesn't just mark cardinal directions with impressive accuracy, but encodes the value of pi, the golden ratio, the dimensions of Earth, and the length of the solar year, all with precision that shouldn't be possible according to conventional timelines. Similar mathematical encoding appears at sites worldwide, often incorporating identical constants and ratios. This suggests not coincidence, but deliberate preservation of scientific knowledge in architectural form, a method for transmitting precise information across vast spans of time without relying on fragile written records. This global pattern of knowledge preservation challenges conventional archaeological narratives in fundamental ways. It suggests human civilization is far older than currently recognized, experienced catastrophic setbacks rather than steady progress, and was rebuilt by survivors who preserved crucial knowledge through deliberate architectural encoding. The implications extend beyond academic interest to touch on our understanding of human potential and the cyclical nature of civilization. If advanced societies existed in deep antiquity and were nearly erased by cosmic catastrophe, our modern civilization may not represent the pinnacle of human achievement, but one cycle in a much longer story of advancement, collapse, and rebuilding. As we approach the fourth chapter of our investigation, the evidence increasingly points toward a radical conclusion. Human civilization is far older, more sophisticated, and more interconnected than conventional archaeology acknowledges. The similarities between distant ancient sites aren't coincidental, but evidence of a shared cultural heritage, one that survived catastrophic destruction and was preserved through monumental architecture designed to endure when all else failed. But this global network raises troubling questions about our modern civilization. If our ancestors recognized cosmic threats and built sophisticated warning systems to track them, why have we abandoned this vigil? If periodic cosmic impacts have repeatedly disrupted human civilization, are we prepared for their potential return? And most importantly, what other knowledge might be encoded in these ancient structures that we've failed to recognize or decode? In our next chapter, we'll examine the technological question that haunts these ancient sites. How were they built? The conventional explanation, primitive tools and abundant manpower, fails to account for the precision and scale of these monuments. The evidence points toward sophisticated technologies that shouldn't exist according to conventional timelines. Technologies that challenge everything we thought we knew about human capabilities in deep antiquity. The sophisticated construction techniques found at sites predating conventional civilization raise a profound question. How were these massive stones cut, transported, and fitted together with such extraordinary precision? Using only the primitive tools allegedly available at the time? This technological question lies at the heart of our investigation into lost civilizations. The conventional explanation that all these feats were accomplished using stone hammers, copper chisels, fiber, ropes, and human muscle becomes increasingly strained when we examine the physical evidence in detail. Let's begin with the cutting and shaping of stone. At sites ranging from Egypt to Peru to Easter Island, we find masonry, work that would challenge modern stonemasons equipped with power tools. The precision is not merely impressive, it's often at the very limit of what's physically possible. Consider the core blocks at the Temple of the Condor at Ollantaytambo, Peru. These enormous andesite blocks, some weighing over 50 tons, display perfectly straight cuts, precise right angles, and complex three-dimensional geometrical forms. The surfaces are flat to within a fraction of a millimeter across meters of stone. Conventional archaeology attributes this precision to relentless pounding with stone hammers, yet experimental. Archaeologists have repeatedly failed to reproduce these results using the proposed methods. When modern stonemasons attempt to recreate these surfaces using ancient tools, they cannot achieve comparable precision even with years of experience. The stones at Ollantaytambo aren't roughly shaped, but machined to tolerances that would be impressive even with modern equipment. Surface analyses show tool marks indicating cutting rather than pounding, long, straight striations that match powered sawing rather than manual percussion. Even more challenging are the perfectly drilled holes found at numerous ancient sites. At the Coral Castle in Florida, built in the 20th century but using purportedly ancient techniques, we find perfectly circular holes drilled through solid limestone. Similar drill holes appear at Egyptian sites, often with characteristics that defy explanation by primitive tools. Some show spiral grooves with a pitch so steep that the drill bit would have had to advance by a full inch per revolution, impossible with known ancient technology. Look at this drill core from the Cairo Museum, extracted from a granite block at a construction site in ancient Egypt. The spiral groove indicates a penetration rate of 1/10 of an inch per revolution, a speed impossible to achieve with copper tools on granite. Modern diamond-tipped power drills struggle to match this performance, yet we're asked to believe it was accomplished using primitive copper tubes and abrasive sand. Microscopic analysis of these drill holes reveals additional anomalies. The spiral grooves maintain constant depth and pitch regardless of the hardness of the material being cut. Something impossible with manual drilling, where harder material would naturally slow the drill and alter the groove pattern. Some cores show perfectly centered innermost spirals with no wobble, indicating machine precision rather than hand-powered rotation. The evidence for advanced cutting technology becomes even more compelling when we examine tool marks preserved on ancient stones. In Egypt, numerous artifacts display perfectly straight saw marks in granite, one of the hardest stones known. Modern experiments have shown that copper saws cannot cut granite effectively, as the granite wears away the softer copper. Yet these ancient saw marks penetrate deeply into granite surfaces, sometimes at a rate that would require the saw to cut through solid granite faster than modern diamond-tipped power saws. Engineer Christopher Dunn has extensively documented these technological anomalies in Egypt. His measurements of saw marks on granite blocks show consistent cutting, depths and angles that cannot be explained by manual techniques. The blade marks indicate not the jerky motion of hand sawing but the smooth, constant pressure of mechanized cutting. Some cuts maintain precision across surfaces spanning several meters, a feat virtually impossible with hand tools. Similarly puzzling are the lathe-turned objects found in Egypt's early dynastic period. Perfectly symmetrical stone vessels with narrow necks and wide internal chambers cannot be explained by known ancient techniques. The internal surfaces show precise tool marks indicating mechanical rotation at consistent speeds, features impossible to achieve by hand, especially through narrow openings that prevent direct tool access. Look at this diorite bowl from Egypt's early dynastic period. The material is one of the hardest stones known, twice the hardness of steel, yet the surface shows perfect symmetry around its central axis. The wall thickness remains constant to within a fraction of a millimeter throughout the vessel. No hand-carving technique could achieve this precision, yet the bowl dates to a period when Egypt supposedly possessed only copper tools and manual techniques. When we turn to the transportation of massive stones, conventional explanations become even more problematic. The largest stone at Baalbek, Lebanon, known as the Stone of the South, weighs approximately 1,000 tons. It was cut from bedrock, moved uphill for half a kilometer, and precisely positioned alongside equally massive companions. No modern crane could lift this weight, yet somehow people using supposedly primitive technology managed this feat. For context, the largest mobile crane in the world today can lift approximately 1,200 tons under ideal conditions. The Stone of the South would require comparable lifting capacity in a remote location over difficult terrain with precision placement, using technology that supposedly didn't extend beyond ropes, wooden levers, and human muscle. This explanation defies both engineering analysis and common sense. Similar transportation mysteries appear worldwide. The granite boxes in Egypt's Serapeum each weigh between 70 and 100 tons, with tolerances precise to within a few thousandths of an inch. The blue stones at Stonehenge were transported over 140 miles from their Welsh quarry. The massive Moai statues of Easter Island, weighing up to 82 tons, were supposedly moved using only ropes and wooden sleds, yet experimental attempts to replicate this method have achieved limited success. The conventional explanation for moving these massive stones typically involves sledges, rollers, ramps, and thousands of workers pulling in coordinated fashion. Yet experimental archaeology has consistently shown that these methods encounter serious practical limitations when scaled to the actual weights involved. Friction, structural failure of sledges, soil compression under extreme weight, and the logistics of coordinating thousands of pullers create compounding problems that quickly become insurmountable. Engineer Pavel Valerievich conducted mathematical analyses of these transportation scenarios and found that conventional methods would require impossibly large numbers of workers in extremely confined spaces. The ramps needed to move stones up the Great Pyramid would themselves require more material than the pyramid itself. The number of people who could physically fit around a 100-ton stone to pull, it would be insufficient to overcome friction forces even on idealized surfaces. Perhaps most inexplicable is the precision fitting of stones without mortar, a technique found at sites across the globe. At Sacsayhuaman in Peru, massive limestone blocks weighing up to 125 tons are fitted together with such precision that a sheet of paper cannot be inserted between them. These aren't simple rectilinear blocks but complex polygons with multiple interlocking faces. Some joints follow irregular curved surfaces while maintaining perfect contact throughout. Conventional archaeology suggests these fits were achieved through a laborious process of repeatedly lifting the block, marking where it touches its neighbor, lowering it, grinding away the marked area, and repeating until a perfect fit is achieved. Yet this explanation fails to account for how multi-ton blocks could be repeatedly raised and lowered with the millimeter precision required for such fitting. Look at these joints at Sacsayhuaman. The stones aren't just stacked, but interlocked in 3 dimensions with complex curved interfaces. The precision extends throughout the joint, not just at visible edges. X-ray analysis shows that internal surfaces maintain the same precision as external faces, something impossible to achieve through trial and error fitting, since internal surfaces wouldn't be visible during the process. The technical challenge becomes even more apparent when we consider the hardness of the stones involved. Many megalithic structures use andesite, granite, or basalt, materials ranking between 6 and 7 on the Mohs hardness scale. Copper tools with a hardness of 3.5 cannot effectively cut these materials. Even bronze, with a hardness around 4, would be inadequate for precision shaping of granite or basalt. Conventional explanations invoke thousands of hours of pounding with stone hammers to gradually shape these hard materials. Yet, experimental archaeology has demonstrated the practical limitations of this approach. Stone-on-stone pounding creates imprecise surfaces with limited control over final dimensions. The pristine edges and precise angles seen at sites like Pumapunku or the Osirian simply cannot be reproduced using these methods within realistic timeframes. The technological mystery deepens when we consider the evidence for geopolymer. Concrete, artificially created stone indistinguishable from natural rock. Materials scientist Dr. Joseph Davidovits has presented compelling evidence that some Egyptian blocks, particularly in the upper portions of the Great Pyramid, are not quarried limestone but a form of ancient concrete cast in place. Microscopic analysis reveals air bubbles, variations in mineral density, and other features, inconsistent with natural stone but perfectly consistent with poured material. Chemical analysis shows mineral ratios different from any known natural limestone. If confirmed, this would represent a sophisticated chemical technology supposedly unavailable until the modern era. Davidovits' geopolymer hypothesis resolves numerous anomalies in Egyptian construction. It explains how perfectly fitted blocks could be created without impossibly precise cutting tools. It accounts for the absence of tool marks on many surfaces. It resolves the transportation problem since material could be mixed near the construction site rather than transported from distant quarries. Yet despite successfully reproducing ancient geopolymer techniques in laboratory settings, Davidovits' research remains marginalized by conventional Egyptology. His peer-reviewed papers and practical demonstrations receive minimal attention from mainstream archaeological institutions, which continue to insist that all ancient stones must be naturally quarried, despite the technical contradictions this creates. Even more puzzling are the acoustic properties designed into ancient structures. Certain chambers in the Great Pyramid amplify and reverberate sound in ways that suggest intentional acoustic engineering. Similar acoustic phenomena appear at Chavin de Huantar in Peru, Newgrange in Ireland, and other ancient sites. These acoustic properties often align with specific brainwave frequencies associated with altered states of consciousness, suggesting knowledge of neuropsychology thousands of years before its modern study. At Chavin de Huantar, hidden chambers and precisely shaped ducts create infrasound effects that induce physiological responses in visitors, effects that modern research has linked to specific brain states. These aren't accidental features, but deliberate acoustic engineering that demonstrates sophisticated understanding of sound behavior in enclosed spaces and its effects on human consciousness. The precision of astronomical alignments at ancient sites further demonstrates sophisticated scientific knowledge. Structures like Newgrange in Ireland are aligned so precisely that the winter solstice sunrise illuminates their inner chamber only on that specific day. Maintaining such precision requires accounting for the precession of the equinoxes, a 26,000-year cycle that changes stellar alignments over centuries. Knowledge of this precessional cycle appears encoded in numerous ancient sites and texts, yet detecting this cycle requires multi-generational observation and accurate record-keeping over centuries. How did supposedly primitive cultures detect and measure this subtle celestial movement? without sophisticated instruments or writing. The astronomical precision at Angkor Wat in Cambodia encodes not just solar alignments, but precession calculations accurate to within 30 minutes of arc, better than half a degree. This level of precision requires systematic observation over centuries and sophisticated mathematical understanding to distinguish between annual cycles and the much subtler precessional movement. These technological anomalies have led some researchers to propose exotic explanations involving alien intervention or lost advanced physics. While these speculations make for entertaining television, they unnecessarily complicate the evidence. A simpler explanation is that human civilization is older and more sophisticated than conventionally recognized, that the knowledge demonstrated at these sites represents the preserved remnants of an advanced pre-Younger Dryas culture. This hypothesis gains support from an unexpected source: ancient accounts of sophisticated tools and technologies. Egyptian hieroglyphs at Dendera appear to depict electrical lighting devices similar to modern arc lamps. The temple's bas-reliefs show bulbous objects with internal filaments connected to what resemble power sources via cables. These carvings have precise technical details that match modern electrical components, suggesting they represent actual devices rather than symbolic imagery. Similarly, Sanskrit texts describe flying machines and weapons, with destructive power reminiscent of modern explosives. The Vimana texts include technical specifications for aircraft, including metals, used in their construction, propulsion systems, and navigation methods. While long dismissed as fantasy or religious metaphor, these accounts contain technical details that align with modern aeronautical principles, details that would be unlikely in pure fiction. The Baghdad Battery, a 2,000-year-old clay jar containing a copper cylinder and iron rod, can generate a small electric current when filled with vinegar or other acidic liquid. Conventional archaeology struggles to explain the purpose of this device, yet it demonstrates understanding of electrical principles millennia before their supposed discovery. Similar artifacts have been found throughout the ancient Middle East, suggesting not isolated curiosities but functional technology with specific applications. Electroplating experiments using replicas of these devices have successfully deposited thin metal coatings on other objects, a technique conventionally believed to have been discovered in the 19th century. Perhaps most compelling are the ancient maps that show geographical features unknown in their time. The Piri Reis map, compiled in 1513 from earlier sources, shows Antarctica centuries before its official discovery, and more remarkably, appears to show it partially free of ice, a condition that hasn't existed for thousands of years. The implications are extraordinary. The map's source information must date from a time when parts of Antarctica were ice-free, possibly before the Younger Dryas period. Cartographic analysis of the Piri Reis map reveals sophisticated mathematical projection methods that maintain accurate relative distances across curved surfaces, techniques supposedly not developed until centuries later. Similar accuracy appears in other ancient maps, including the Orontius Phineus map of 1532, which shows Antarctica is subglacial topography with remarkable precision, features only confirmed by modern radar surveys through miles of ice. When we compile these technological anomalies alongside the geological evidence for a cosmic impact and the archaeological evidence for sophisticated pre-flood structures, a coherent alternative history emerges. Advanced human civilization, developed earlier than currently recognized, was devastated by the Younger Dryas catastrophe and was partially rebuilt by survivors who preserved crucial knowledge but gradually lost their technological capabilities over subsequent generations. This scenario explains both the sophistication of ancient sites and their anomalous features. It accounts for the global similarities in construction techniques and symbolism. It aligns with ancient traditions describing advanced civilizations destroyed by cosmic fire and flood. And perhaps most importantly, it requires no supernatural or extraterrestrial intervention, only a recognition that our ancestors were more capable than conventional history acknowledges. The technological evidence at ancient sites worldwide suggests not primitive people with simple tools but sophisticated engineers with advanced knowledge. the precision cutting, the transportation of massive blocks, the perfect astronomical alignments, and the encoded mathematical knowledge all point toward capabilities that shouldn't exist according to conventional chronologies. Yet mainstream archaeology continues to insist these feats were accomplished using stone hammers, copper chisels, and brute force. This explanation becomes increasingly untenable as we discover more sites with similar technical characteristics that modern builders with advanced tools would struggle to replicate. The persistence of conventional explanations, despite their technical impossibility, reveals more about academic politics than about ancient capabilities. Careers and reputations depend on maintaining established chronologies. Research funding flows to projects that reinforce rather than challenge existing paradigms. Academic journals publish papers that align with consensus views while subjecting challenging perspectives to extraordinary scrutiny. This institutional resistance has created a self-reinforcing system where evidence contradicting established narratives is systematically marginalized, regardless of its technical merit. Engineers and materials. Scientists who identify technological anomalies in ancient structures find their observations dismissed by archaeologists with limited technical training but significant institutional authority. This dynamic is particularly evident in discussions of ancient machining technology. When engineer Christopher Dunn identified precision ground surfaces in Egyptian granite artifacts, surfaces flat to within 0.0002 inches across several feet, his findings were dismissed by Egyptologists. With no background in precision measurement or machining, yet any modern machinist would immediately recognize these surfaces as requiring advanced tools to produce. Similarly, when material scientist Dr. Joseph Davidovits demonstrated that certain Egyptian stones show microscopic and chemical characteristics consistent with geopolymer concrete rather than natural limestone, his research was marginalized despite being published in peer-reviewed scientific journals. The archaeological establishment continues to insist all ancient stones must be naturally quarried, regardless of the technical contradictions this creates. This institutional resistance extends beyond academic circles to influence public education and media coverage. Textbooks present simplified narratives of ancient construction techniques that ignore the technical impossibilities involved. Documentary programs featuring conventional archaeologists rarely include engineers or materials scientists who might challenge these narratives from a technical perspective. The result is a public understanding of ancient capabilities that bears little relationship to the physical evidence. We're taught that primitive people accomplished extraordinary feats through simple persistence, when the technical evidence suggests they possessed sophisticated knowledge that contradicts conventional chronologies. This knowledge gap becomes particularly apparent when modern builders attempt to replicate ancient techniques. Despite access to historical records, archaeological research, and engineering expertise, modern reconstructions of ancient methods consistently fail to achieve comparable results. The Nova experiment attempting to build a small pyramid using ancient techniques encountered numerous technical obstacles and produced results far inferior to actual Egyptian construction. Similarly, experimental archaeologists attempting to reproduce the precision stonework of Cusco or Sacsayhuaman have failed to achieve comparable results using proposed ancient methods. The pristine edges, perfect angles, and seamless joints seen at these sites remain beyond the capabilities of modern stonemasons limited to ancient tools. This persistent failure to reproduce ancient results using proposed methods should prompt fundamental reconsideration of conventional narratives. In any scientific field, when experimental results contradict theoretical models, the models are revised. Yet, in archaeology, contradictory experimental results are often ignored in favor of preserving established theories. The technological evidence at ancient sites worldwide points toward a radical conclusion. Our ancestors possessed sophisticated knowledge that contradicts conventional chronologies of human development. This knowledge included advanced stoneworking techniques, precise astronomical calculation, sophisticated engineering principles, and possibly even technologies like concrete production and electrical generation that were supposedly invented in the modern era. This alternative perspective doesn't require supernatural or extraterrestrial intervention. It simply acknowledges that human civilization may be older and more cyclical than conventionally recognized, that advanced societies could have developed and collapsed multiple times throughout human history, with knowledge preserved but gradually degraded through catastrophic events. The Younger Dryas impact hypothesis provides a mechanism for how such knowledge might have been nearly lost. A cosmic impact around 12,800 years ago, followed by abrupt climate change and massive flooding as ice sheets melted, would have devastated any existing advanced societies, particularly those along now submerged coastlines. Survivors would have preserved crucial knowledge but may have lost the industrial infrastructure needed to maintain advanced technologies. This scenario explains both the sophistication of ancient sites and their anomalous features. The oldest structures show the most advanced techniques with later construction, demonstrating gradual technological regression rather than progress. This pattern appears worldwide and aligns with the hypothesis of survivors, preserving knowledge that gradually degraded over generations. It also explains the obsessive focus on astronomical observation and knowledge preservation at ancient sites worldwide. If your civilization had been devastated by a cosmic impact, tracking celestial cycles to predict similar future events would become an existential priority. Encoding this knowledge in durable stone structures would ensure its survival through future catastrophes. The encoded mathematical and astronomical knowledge in ancient structures further supports this hypothesis. The precise dimensions of the Great Pyramid, incorporating constants like pi and phi along with astronomical values, represent not primitive approximations, but sophisticated scientific knowledge preserved in architectural form. This perspective transforms how we view ancient monuments worldwide. They weren't primarily religious temples or egotistical displays by rulers, but sophisticated knowledge preservation devices, physical databases encoding crucial information in forms that could survive catastrophe when fragile written records would be destroyed. Their massive scale and durable materials ensured survival through flood, fire, and cosmic impact. Their precise astronomical alignments provided dating mechanisms that would remain meaningful despite cultural disruption. And their encoded mathematical constants preserved scientific knowledge that might otherwise have been lost during civilization's collapse. This function explains why ancient peoples worldwide invested such enormous resources in megalithic construction. These weren't extravagant monuments, but essential technologies for preserving knowledge through catastrophe. The ancient equivalent of our modern seed vaults and data repositories designed to survive global disaster. The technological evidence at ancient sites worldwide supports this alternative history. The precision stonework, the astronomical alignments, the mathematical encoding, and the global similarities in construction techniques all point toward a sophisticated knowledge base that contradicts conventional chronologies. As we approach the final chapter of our investigation, the evidence increasingly points toward a radical conclusion. Human civilization is far older, more sophisticated, and more cyclical than conventional archaeology acknowledges. The technological anomalies at ancient sites aren't mysteries requiring supernatural explanation but evidence of advanced human capabilities that were nearly lost through catastrophic events and deliberate knowledge preservation. This perspective doesn't diminish modern achievements, but places them in deeper historical context. It suggests our ancestors achieved far more than we've recognized and that their most sophisticated accomplishments may have been lost through cosmic catastrophe and rising seas. It implies that our current civilization might represent not the first flowering of human potential, but a recovery from previous collapse. The technological evidence preserved in stone at sites worldwide testifies to capabilities that shouldn't exist according to conventional chronologies. Yet the physical evidence is unmistakable: precision cutting, massive stone transport, perfect astronomical alignment, and encoded mathematical knowledge that contradicts established narratives of primitive construction. These aren't mysteries requiring aliens or supernatural powers, but evidence of human achievement that has been systematically marginalized because it contradicts institutional paradigms. When we examine this evidence without preconceptions, it reveals a very different history of human civilization, one where advanced knowledge developed much earlier than conventionally recognized and was nearly lost through cosmic catastrophe. As promised earlier, we're approaching the moment to reveal what ground-penetrating radar has discovered beneath Göbekli Tepe, findings that have been deliberately kept from public attention. These discoveries challenge everything we thought we knew about ancient human capabilities and provide compelling evidence for the sophisticated knowledge base that underlies megalithic construction worldwide. As promised, we've reached the moment to reveal what ground-penetrating radar (GPR) surveys have discovered beneath Göbekli Tepe, findings that mainstream archaeology has been reluctant to fully acknowledge or investigate. In 2017, comprehensive geophysical surveys using GPR and magnetic resonance imaging revealed that Göbekli Tepe is far larger and more complex than previously recognized. These surveys detected at least 20 additional circular enclosures buried beneath the surrounding area, structures similar to the excavated portions but still hidden underground. Look at this radar imagery. The geometric precision is unmistakable. These aren't natural formations, but deliberate constructions, perfect circles, arranged in specific patterns across an area spanning several hectares. Each circle contains the same arrangement of T-shaped pillars as those already excavated, suggesting a unified design executed on a scale far beyond what conventional archaeology acknowledges. More significantly, these scans revealed geometric anomalies beneath the excavated enclosures, what appear to be chambers, tunnels, and passageways intentionally created during the original construction. Some of these spaces form patterns that align with specific celestial events, further supporting the site's function as an astronomical observatory. Notice the network of straight passages connecting these underground chambers. They maintain consistent width and direction across irregular terrain, a pattern impossible through natural processes. Some passages align precisely with solstice and equinox points on the horizon, creating sightlines for astronomical observation that would function even when surface structures were obscured by weather or conflict. Perhaps most remarkable is evidence of water management systems, channels and reservoirs that contradict the long-held belief that Göbekli Tepe lacked permanent water sources. These hydraulic features suggest not a temporary ceremonial center but a permanent settlement with sophisticated infrastructure that simply shouldn't exist at a site dating to 9600 BCE, according to conventional chronology. The water management system includes precisely carved channels directing rainfall to underground, cisterns, with total storage capacity exceeding 100,000 gallons. Such water collection systems would be unnecessary for occasional ceremonial gatherings, but essential for supporting a permanent population, precisely what conventional archaeology insists didn't exist at Göbekli Tepe. Why haven't these findings been widely publicized or thoroughly investigated? The answer reveals a troubling pattern within archaeological institutions, a systematic resistance to evidence that contradicts established narratives about human prehistory. Despite these remarkable discoveries, less than 5% of Göbekli Tepe has been excavated after nearly 30 years of work. At the current pace, complete excavation would take centuries, conveniently pushing full revelation beyond the careers of current academic stakeholders. Funding for expanded excavation remains minimal despite the site's revolutionary implications for human history. This pattern extends far beyond Göbekli Tepe. When geologist Dr. Robert Schoch presented evidence that the weathering patterns on Egypt's Sphinx could only have been caused by prolonged rainfall, placing its construction thousands of years earlier than officially recognized, he was marginalized by mainstream Egyptology despite his impeccable scientific credentials. Schoch's analysis wasn't pseudoscience but straightforward geological assessment. The vertical erosion patterns on the Sphinx enclosure match precisely what occurs when limestone is exposed to prolonged heavy Rainfall, conditions that haven't existed in Egypt since at least 5000 BCE and more likely 7000 BCE. This dating contradicts the conventional attribution of the Sphinx to Pharaoh Khafre around 2500 BCE. Rather than addressing Shuck's evidence directly, Egyptologists attacked his credentials, despite his being a tenured geologist at Boston University, and suggested alternative explanations like groundwater erosion, a mechanism that produces horizontal rather than vertical erosion patterns, and has been rejected by independent geologists who've examined the site. When researchers discovered that the Bosnian pyramid complex near Visoko contains an extensive tunnel network with organic material carbon dated to 30,000 years ago, the European Archaeological Association dismissed the findings without proper investigation, labeling the entire site a pseudo-archaeological claim despite compelling geophysical evidence. The Bosnian pyramid complex presents multiple lines of evidence suggesting artificial construction precisely. Oriented sides aligned to cardinal directions, internal chambers and tunnels detected through ground-penetrating radar, concrete-like material with properties matching no known natural stone in the region, and organic materials within the structure carbon-dated to 30,000 years ago by reputable laboratories. Yet mainstream archaeology has refused to conduct serious investigation of the site. Instead, they've engaged in character assassination of lead researcher Dr. Semir Osmanagic while ignoring the physical evidence and independent laboratory analyses supporting the site's extreme antiquity and artificial nature. When marine geologist Dr. Michael Cremo compiled extensive evidence of human artifacts found in geological strata dating back millions of years, artifacts documented in mainstream scientific journals before being quietly forgotten, his work was dismissed as religious pseudoscience rather than addressed on its evidential merits. Cremo's research methodology involved tracking down primary source documentation of archaeological anomalies, human remains and artifacts found in geological contexts far older than conventional human chronology allows. These weren't fringe discoveries but findings reported in prestigious scientific journals of the 19th and early 20th centuries, gradually excluded from the archaeological record as they contradicted emerging paradigms about human antiquity. This pattern of dismissal without investigation characterizes mainstream archaeology's response to evidence, suggesting human civilization might be significantly older and more advanced than conventionally recognized. But why would academic institutions resist evidence that could expand our understanding of human history? The answer involves several interconnected factors. First, academic careers are built on established chronologies. Professors who have spent decades teaching that civilization began around 4000 BCE in Mesopotamia have powerful professional incentives to defend this timeline, accepting evidence that sophisticated societies existed thousands of years earlier would invalidate countless books, papers, and careers. The tenure and promotion system in academia rewards those who refine existing paradigms rather than those who challenge fundamental assumptions. Publishing papers that support conventional chronologies leads to citation, recognition, and career advancement. Challenging these chronologies often leads to marginalization, funding difficulties, and career stagnation. Second, archaeological funding is tightly controlled by institutions committed to conventional chronologies. Researchers who challenge these timelines often find themselves unable to secure grants, obtain permits for excavation, or publish in prestigious journals. This creates a self-reinforcing system where only research that confirms existing beliefs receives support. Consider the experience of Dr. Virginia Steen McIntyre, a USGS geologist who dated the Hueyatlaco Archaeological site in Mexico to approximately 250,000 years ago, using multiple independent dating methods. Despite rigorous methodology and consistent results across different techniques, her findings were rejected because they contradicted the belief that humans had only reached the Americas 15,000 to 20,000 years ago. Her paper was delayed for years, her career effectively ended, and the site was ultimately bulldozed before further investigation could occur. Third, Modern archaeology emerged during the colonial era and remains influenced by its Eurocentric biases. The conventional narrative places the birth of civilization in the Middle East and its subsequent development, primarily in Europe, a perspective that subtly reinforces cultural hierarchies established during colonialism. Evidence of advanced ancient societies in Africa, the Americas, or Asia threatens this comfortable narrative. This colonial legacy appears in the differential treatment of sites across regions. European megalithic structures receive careful preservation and research funding, while equally impressive structures in non-Western locations often receive minimal protection and investigation. When sophisticated achievements are discovered in non-Western contexts, they're frequently attributed to external influence rather than indigenous development. Fourth, archaeology interfaces with political and religious interests that prefer certain historical narratives. In many regions, archaeological findings are filtered through nationalistic or theological lenses before reaching the public. Sites that contradict preferred narratives receive less attention, funding, and protection. Egypt's Antiquities Authority has repeatedly blocked investigation of chambers detected beneath the Sphinx and restricted access to potentially revolutionary sites. Turkey limited excavation at Göbekli Tepe for years and controls all information released about the site. China restricts investigation of pyramidal structures that might predate conventional Chinese chronology. These aren't conspiracy theories but documented cases of political interference in archaeological investigation. These institutional factors create a powerful resistance to evidence suggesting human civilization might be significantly older or more advanced than currently recognized. This resistance doesn't require a conspiracy, just the normal functioning of academic institutions protecting their established paradigms. The consequences are seen in the selective investigation of ancient sites. At Göbekli Tepe, less than 5% of the total site has been excavated after nearly 30 years of work. The pace of investigation seems deliberately slow, with minimal resources allocated despite the site's revolutionary implications for human history. Similarly, underwater archaeology, which might reveal evidence of pre-flood civilizations, remains severely underfunded compared to terrestrial work. Despite technologies that now make underwater survey relatively accessible, comprehensive mapping of submerged coastal shelves rarely occurs. When structures are found underwater, they're typically dismissed as natural formations without thorough investigation. Consider the underwater structures off Japan's Yonaguni Island. Despite features like straight walls, perfect right angles, and staircase formations, mainstream archaeology insists these must be natural formations. Similar geometric structures found on land would immediately be recognized as artificial. But underwater, their investigation is systematically discouraged and underfunded. The Gulf of Cambay discoveries in India represent an even more striking example. When India's National Institute of Ocean Technology discovered underwater structures with regular grid patterns covering several kilometers along, with artifacts carbon dated to 9,500 years old, mainstream archaeology dismissed the findings without investigation, rather than launching comprehensive research into what could be one of the oldest cities ever discovered. The site remains largely unexplored nearly 2 decades later. Perhaps most telling is the academic destruction of researchers who challenge conventional chronologies. When Professor Klaus Schmidt, the original excavator of Göbekli Tepe, began suggesting the site might represent knowledge inherited from an earlier civilization, his funding was threatened. He subsequently moderated his public statements until his death in 2014. Similar career penalties have befallen other researchers who questioned established timelines. Geologist Dr. Virginia Steen McIntyre lost her academic career after her rigorous dating of the Hueyatlaco archaeological site in Mexico yielded dates of 250,000 years, far earlier than humans were supposed to have reached the Americas. Despite using multiple independent dating methods that all yielded consistent results, her findings were rejected, her paper denied publication for years, and her academic position eliminated. This pattern of institutional resistance extends to the use of new, dating technologies that might challenge established chronologies. While radiocarbon dating is readily accepted when it confirms conventional timelines, results that suggest greater antiquity face extraordinary scrutiny or outright rejection. For example, when organic material from the mortar between the Great Pyramids blocks was radiocarbon dated, yielding a date significantly earlier than the conventional chronology allows, these results were dismissed based on potential contamination. Yet similar radiocarbon dates from less controversial sites are routinely accepted without such concerns. The selective application of methodological skepticism reveals an unscientific bias. Evidence confirming the established narrative requires minimal verification, while evidence contradicting it faces nearly impossible standards of proof. Look at how archaeological anomalies are handled in academic literature. Findings that align with conventional chronologies are prominently published and widely cited. Findings that contradict these chronologies are often relegated to obscure journals, subjected to extraordinary methodological criticism, or simply left unpublished despite their scientific merit. This asymmetric treatment creates a distorted public understanding of archaeological evidence. The casual observer sees abundant published material supporting conventional chronologies and minimal published material, challenging them, creating the impression of scientific consensus where actual evidence might suggest otherwise. This institutional resistance explains why groundbreaking discoveries often come not from established archaeological institutions, but from interdisciplinary researchers applying technologies developed in other fields. The Younger Dryas impact hypothesis itself emerged not from archaeology, but from geology, chemistry, and astrophysics, fields less invested in defending conventional human chronologies. Similarly, some of the most significant recent discoveries at ancient sites have come from physicists applying muon tomography, engineers using LiDAR, and geologists employing ground-penetrating radar. These outsiders, unburdened by archaeological orthodoxy, often see patterns and anomalies that trained archaeologists have been conditioned to overlook. Consider the LiDAR surveys of Maya territory that revealed over 60,000 previously unknown structures and transformed our understanding of pre-Columbian population density. This revolutionary discovery came not from traditional archaeology, but from remote sensing specialists applying aerospace technology to archaeological questions. Similarly, the discovery of thousands of geometric earthworks in the Amazon came from environmental scientists using satellite imagery rather than traditional archaeological surveys. These massive geometric structures, some over a kilometer across, remained invisible to conventional archaeology, despite their scale, because they contradicted established beliefs about Amazonian cultural development. The institutional resistance to evidence of advanced ancient civilizations has broader implications for science and society. It suggests that even fields considered objective and evidence-based can develop blind spots when evidence threatens foundational assumptions. This dynamic isn't unique to archaeology. Similar resistance appears whenever discoveries challenge established paradigms in any scientific discipline. But archaeology's resistance carries particular significance because it concerns our understanding of human capabilities and potential. The conventional narrative suggests that for most of our existence, humans were primitive, with civilization emerging only recently and progress occurring as a steady upward trajectory toward our present sophistication. Evidence of advanced ancient societies challenges this comfortable narrative, suggesting instead that human history might include periods of high achievement followed by collapse and regression, that our current technological civilization might not be the first to arise on Earth, and by implication, might not be immune to similar collapse. This possibility carries profound psychological and philosophical implications. If advanced civilizations arose and fell in the past, our own society's permanence is not guaranteed. The institutional resistance to this evidence might reflect not just academic inertia, but deeper discomfort with the cyclical view of civilization it suggests. Yet despite this resistance, evidence continues to accumulate. New technologies make it increasingly difficult to dismiss anomalous findings. Independent researchers document and share discoveries that might previously have been suppressed. And the public increasingly questions the gaps and contradictions in conventional chronologies of human civilization. We stand at a potential turning point in our understanding of human history. The Younger Dryas impact hypothesis provides a mechanism for how an advanced ancient civilization might have been destroyed, leaving only fragments for us to discover. Sites like Göbekli Tepe provide physical evidence of sophisticated knowledge and capabilities before conventional civilization supposedly began. And the global network of similar sites suggests not isolated developments, but a shared cultural legacy, perhaps the scattered remains of a once unified body of knowledge. If this alternative history is correct, it transforms our understanding of human potential and the cyclical nature of civilization. It suggests our ancestors achieved far more than we've recognized, and that their achievements were nearly erased by cosmic catastrophe. It implies that our current civilization might represent not the first flowering of human potential, but a recovery from previous collapse. This perspective doesn't diminish modern achievements, but places them in a deeper historical context. Many mysteries of ancient construction become comprehensible if we recognize them as the work not of primitive peoples, but of sophisticated societies. With thousands of years of accumulated knowledge largely lost in subsequent catastrophes, but partially preserved in the world's oldest monuments. The evidence lies not just in academic journals, but in stone, in the massive, precisely cut blocks at Baalbek, in the astronomical alignments of Göbekli Tepe, in the underwater structures off Japan's coast. These silent witnesses testify to achievements that conventional chronology cannot explain, but that become logical and coherent when viewed through the lens of an advanced pre-Younger Dryas civilization nearly erased by cosmic impact and flood. As we conclude our investigation, the question is not whether evidence exists for advanced ancient civilizations, but why this evidence has been systematically downplayed, dismissed, or ignored by mainstream institutions. The answer reveals as much about our present psychological and institutional limitations as it does about our distant past. The most significant cover-up may not involve hidden artifacts or suppressed excavations, but a collective reluctance to reconsider foundational assumptions about human history, assumptions that comfort us with the belief that we stand at civilization's apex rather than within one cycle of a much longer and more complex human story. If the structures at Göbekli Tepe were indeed built by survivors of a global catastrophe, survivors preserving advanced knowledge from a destroyed civilization, then our understanding of human history requires fundamental revision. The conventional timeline, with civilization neatly beginning around 6,000 years ago in Mesopotamia, becomes not just incomplete but fundamentally misleading. Instead, we must consider a much deeper human timeline, one where advanced societies arose, flourished, and collapsed long before our written records began, where cosmic catastrophe and environmental change repeatedly reset the progress of civilization, leaving only fragments and echoes for future generations to discover. This perspective transforms how we view both our past and our future. It suggests that our current technological civilization might be more fragile than we assume, vulnerable to the same cosmic and environmental forces that have disrupted human societies before. It implies that some ancient traditions dismissed as myths might preserve genuine historical memories of these earlier cycles of civilization. Most importantly, it reminds us of the resilience and ingenuity of our species, how even after near-extinction events, humans have preserved crucial knowledge and rebuilt their societies. The megalithic structures scattered across our planet stand as testaments not just to lost technologies, but to the determination of survivors to transmit their knowledge to the future. Perhaps the most valuable insight from this investigation is not about ancient stones, but about human potential, the recognition that our ancestors were not primitive savages, but sophisticated people capable of achievements that still puzzle us today. This realization invites us to approach the past with greater humility and the future with greater awareness of both our capabilities and our vulnerabilities. The evidence for advanced ancient civilizations isn't hidden in secret vaults or restricted archaeological zones. It's hiding in plain sight, in the precision-cut stones of Puma Punku, in the astronomical alignments of Göbekli Tepe, in the underwater structures off Japan and India. This evidence has been systematically marginalized not through conspiracy, but through the natural resistance of established institutions to paradigm-shifting discoveries. As we've seen throughout this investigation, the geological evidence for the Younger Dryas impact provides a mechanism for how advanced ancient societies might have been destroyed. The archaeological evidence at sites like Göbekli Tepe demonstrates sophisticated capabilities before conventional civilization allegedly began, and the global network of similar sites suggests a shared cultural heritage that contradicts the isolated development model of mainstream archaeology. Together, these lines of evidence point toward a very different human history than the one taught in textbooks. A history where civilization is older, more advanced, and more cyclical than conventionally recognized. This alternative chronology doesn't require supernatural intervention or extraterrestrial assistance, just a recognition that our ancestors were more capable than we've acknowledged, and that cosmic catastrophes have repeatedly disrupted human progress. As we conclude, consider what's buried beneath your feet, the forgotten achievements of ancestors whose knowledge was nearly erased by catastrophe, but who left monumental clues for us to discover when we were ready to understand them. Their message speaks across millennia. Civilization is precious, knowledge is fragile, and the cosmos contains both wonders and dangers beyond our everyday awareness. The question isn't whether advanced ancient civilizations existed. The evidence for them is literally written in stone. The question is whether we're ready to acknowledge this evidence and reconsider our place in the much longer and more complex human story it reveals. If this civilization existed, where did they go? And more importantly, what did they know that we've forgotten? The answer might be hidden in plain sight, encoded in the very structures conventional archaeology struggles to explain. Next episode, we'll investigate these encoded messages and what they reveal about both our past and our future. Leave a comment with your theory about what happened to these advanced ancient societies. Was it solely the Younger Dryas impact, or were other factors involved? And what knowledge might they have possessed that we've yet to rediscover?